Okay, I'll see if I get, yeah, I've got some vocal. Let's see who is here. And Suzanne and Alexa, glad to see you too. Please make sure that you have your your audio muted and your video too. Now, if you have a question, you can send me a chat message and I can try to answer it. We've got a few minutes here and then I'll go ahead and get started with the class. So it's going to be about 2 or 3, 4 minutes. I think we'll have some people show up, maybe not. We'll see. We'll talk about what's going on in the course and where we are. All right. I'll make sure I'm still got it. Yeah, okay, good. I'm still there. And I think I'll go ahead and get us started because those who come in late, they can catch this on the front end when I record this and save it. And I'm going to go ahead and get us started. Again, thank you, the two of you here. Anybody else who should come in a little bit late, don't worry about it. You can just catch it on the front end. This is we have the class of the 25th, the 27th and the 29th. And what we're going to do today is we're going to review the leisure case and then try to take a look at some materials for Wednesday, which is the I know Wednesday I'll do a screencast of the county case. I think we may try to take a look also at the Foster case today as well. I do want to spend some time on leisure. Now again, if you missed a little bit, you can always catch it on the front end on the recording. This the leisure case is over there on pages 224 to 229, basically. And this is a management revenue problem that we're asked to deal with. And I want to, let's see, take a look up here for just a moment where I put leisure. I'll put in the modules. Pardon me, in the syllabus part. And we were going to do some manipulation of some of the variables that they had. Okay, yeah. Now, just so that you see, and this should be over there. This is a maximization problem and a revenue management problem, and we're going to try to compute the maximum revenue using these changes in the leg and the demand, the change in the fare for a particular leg of flights, and then a change in demand, and then yet another change there as well. Now, the files for this case and the key for it I have over here. I think I have a file called Leisure Key, if I'm not mistaken. That's it. And I'm going to publish it so everybody can see it. And then we'll talk about it a little bit today and download that. Now, as I said before, if you just try to work one of these problems, I'm good with that. That's why I have these follow-ups and these reviews. See, we've got a couple more people. Josu, glad to have you here. And I see Amanda as well who have joined. Now, we've got this leisure key, and I'm going to open it up for just a second. Okay, and I should, if I'm not mistaken, I think I threw in the parameters that we were to work with, and we were doing a revenue maximization problem. So I'm going to take this file and I'm going to save it down to my computer, and down to my desktop, and I'm going to save it as Leisure Key. You can see I've had multiple work with this file. So it's down there, and we'll talk about it. And here basically, I'll put this in a little bit bigger font. Okay. And let's talk about this before we do anything. I want to just show you some information I had gotten about this airline, and we'll go back over here to the modules area. So go ahead and download the Excel file, and then we'll we'll take a look at it. The first thing that we have to take a look at is their destination, and I used a tool out there called Easy Map Maker, and these are their destinations. These are the destinations for the airports in each of their addresses and their addresses and their and the name of the airport. Now I'm going to download this for a second. Okay, and then I'm going to diminish this, and I'm going to open up a new tab, and I'm going to go over to Easy Map Maker. That's the one I used, just to kind of get a sense of where these places are located. And we'll create a map from Excel data. And I'm just going to take this data, copy it, and then I'm going to come back over to Easy Map Maker, and I'm going to put it in. And they tell us, create a map, and then click there, and I'm going to paste the data, and then I'll make the map. And it's going to create the map for us. And we had the addresses for each of the airports. And so you can see, this gives you an idea of just the general logistics that they're working with. They've got these flights that run, basically trunk flights that run on the East Coast. And you can see there, they've got a flight down to Orlando, it looks like, and they've got one in South Carolina, they've got one in Pennsylvania and New York. And again, these are just some data for us to kind of put this into perspective. So this is leisure, and I've got that link over there in today. Now, I also have the key over there in the files. I've just published it, so you should be able to get it and download it. You should have already uploaded the work, but I wanted to show you, I want you to attempt to try to work with it, and then I wanted to show you what we were doing. Now, so this gives you a picture of where they're at, okay? And I'm going to go back over here. And that shows you, and that's the data. And I took those destinations and copied and pasted them into a tool called Easy Map Maker. And so that would let us kind of put in into perspective where they fly. And of course, they do a lot of commuter flights. So that's that's a dynamic that's a little different from the larger flights that have a hub and spokes. Now, I also wanted to let you guys see the aircraft that they work with, okay? And I think this link will take you out there. This is the airliner, and so it gets you a sense of the number of people that it can carry. It's a fairly small. There's a picture of the inside of the thing, and gives you a sense of the scope and the scale of the thing. It's not that huge an airplane, and here's some information about its what it can do, its maximum carrying power, its maximum load, etc. So there's some good information there. Now, the other thing that I wanted to show you was and this is over here in the file, this is Seating Secrets. This is an article that takes you out and gives you an idea of how airlines engage and utilize these techniques in optimization techniques in terms of pricing flights and pricing seats. And so it's a pretty interesting little article to see and take a look at. And we'll go up here for just a sec. Starbucks coffees. As an advertisement, but I would leave it to your good devices to go out there and take a look at it. But you could see that folks use these techniques, and pricing seats is one of them. And we've talked about that. This is because they have such an uphill battle in terms of their capital, of their fixed costs. They're so capital intensive that they have to do that. Well, I had asked you guys to work on this case, And so I'm going to take the Leisure Airports thing and shut that off. And then we can take a look at this this model. Now I'd ask you to work with each of the legs. Now, as the text shows you, okay. Now I misstated a moment ago. I forgot they have a hub. Their hub is Charlotte. So if you want to kind of get a sense of that, we can go back over here and you can see where they hub everything into Charlotte, which is, I guess, the most central location. And so they mimic the larger airlines in the sense that they will hub people in, okay, and then back out to wherever they're headed to. But Charlotte is their hub, so they're using a hub and spokes type of method, and they show that there on page 225, and that's not too unusual. What you've got there is a typical kind of star distribution pattern in which you have the distribution is either flowing into some hub and then reworked and redistributed, or it's just simply sent out. It doesn't matter. So, and whoever's there, put your make sure you got your mic on mute. But now, if you can see, they have each of these flights, and they've identified these legs for us here. A leg 2, leg 3, leg 4, leg 1. And you can see as they walk through here, the origin destination itinerary fares. This shows you the fares they in the forecasts demanded as they go across from each of those fares. So you can see they've got those 16 basic flights dealing with the hub, and it shows you the forecast demand, and that becomes an issue where they can just do some simple revenue. Over on page 226, they then begin to walk you through some of the decision variables, okay? And that's trying to figure, okay, what will we do maybe in terms of pricing, all right? What are we going to do? And they're the decision variables in terms of trying to allocate seating. Now, they use the same planes. And so they're all the same model, and they're just so they have the same seating capacity. But the reason they use a hub and spoke is to try to kind of make, if I've got 2 half planes, I try to inbound them so I can have a full plane. That's about as simple as I could possibly say, but that's the hub and spoke system. But they show you those decision variables, okay? And then in the middle of 226, they show you the objective function for that equation. And I've got leg 1 open here, okay? And what I ask you to do is compute the maximum revenue with leg number 1, okay? Assuming a 10% drop of fare and a 10% increment in demand, okay? And so we had the change in fare, okay? And we had the change in demand. Now, what did I do the opposite of this? Is when I do the change in fare is point. Okay, yeah, I dropped the fare there. Okay, now let's take a look at this for just a second, and we'll go over and we'll look at the data, and we'll go over to Solver, and you can see there the decision variables are the decision variables are C25 through C44. Okay, and that's the left-hand side of the equation, the right-hand side of the equation, and all of them are based upon equal to or lesser than these given fares that we're working with here. And now, this is assuming they're using a simplex LP here, they assume that there is a direct correlation in demand and fare. And I'll close this for a second. You can see this. It's okay if we take the fare down 10%, then we'll increase the demand 10%. And that's what the simplex LP assumes, that somewhere or the other, your data represent that type of distribution. Now, all we had to do then was just put in the constraints. Okay, make sure they're we don't have any non-negatives, and we make all the unconstrained variables non-negative. We don't have any negative variables, and so we go in and we do leg 1, okay, and we look at that down 10 plus 10, and what does it look like? And based upon these left hand and right hand equations, this must be equal to or lesser than, and you can see the allocations that we've got for each of those. So that's really all that's going on there. And then we take a look at the second leg. And if you want to follow along, if you take a look over there on page 224, you'll see each of the legs. The first leg of this is Pittsburgh into Charlotte. Okay, now to kind of put that back in perspective, we can go back over here and you can take a look. You've got this first leg. This is over in Pittsburgh, popping down to Charlotte. And so they've got that first leg. Then the second leg now is Newark into Charlotte. Now, my hunch would be that they probably have that type of inbound simply because they probably are going to dump a whole bunch of people in Orlando. But we have that second leg now, and we see a change in fare, and we changed the demand 11%. We changed the fare by 7%. And what does that do in terms of our revenue maximization? Okay, and again, we have the capacity, and we have the ODIF, and the ODIF is origin, destination, itinerary fares. Okay, so we're assuming fares can be no more, must be equal to or less than each of these levels. Okay, now to see what it looks like up here, we changed some of those, and they're playing around. And again, this is leg 2, and as you follow around there on page 225 at the top, that figure, those are the people coming in from New York. Okay, now my hunch would be that you're probably going to have a ton of folks coming in from either one of them. And if you take a look there at leg 3, you're going to see kind of a typical trunk approach. And what they've got is they're what we would call a prevailing northern southern type of logistical network, meaning they've got a bunch of people they're dumping into Charlotte, and then those folks are distributed down south, primarily down to Orlando, because you see them all dumping them into Charlotte and then either Myrtle Beach or over to Orlando. So they're hitting the big population centers. They're basically dealing with the probably business people or probably more likely tourists. And so I just ask you to work with those constraints, okay? And again, compute the maximum revenue. And it's simple. We just pop on the solver, okay, and put in the variables. Make sure we have unconstrained variables, non-negative, simplex, and away we go. Okay. Now, the tricky part of all of this, and let's look at the model for just a minute. This is just the original model. Here's the maximum revenue using it. Here's the maximum revenue with leg 1. Here it is with leg 2, and here it is with leg 3. Okay, doing some changes with those flights. So there's the model, and then I provided you figure 5.5, which is out of the book, which shows you the output. Okay, and that's over on page 228. They show you the solution there. Now, what you'll see there on 228 is the shadow prices, okay, which is the same as the dual value, which is a change in change in one unit. What does it do for the other variable? And then if you notice here, you've got some surplus, slack, i.e. surplus, down here in terms of the values. All right. And you can see the really big one is that 376. That's a really big one. Now, If you look over at page 227, you're going to see the whole model spelled out for you with the maximization laid out there, the objective function, and then subject to, and then there are 4 sets of constraints, and those constraints are Pittsburgh to Charlotte, Newark to Charlotte, and then Charlotte to Myrtle, and Charlotte to Orlando. And then you have below there the demand constraints are the forecasted demand. So the issue for them that's uncontrollable, okay, is the demand issue. That's what they have to try to work and figure out. And that's what I was wanting you to do. Now, if you ran the solver and then you just put the solution in there if you ran solver and then you showed the solution, I'm good with that. Solver does the report just as well. But I took figure 5.5 out and threw it in the Excel sheet so you could see what it looks like. But again, this is, I think they're using that little software program they've got. But you could compare that with what you would get if you ran the demand and then just did, you went ahead and did the report. And well, we can do that. Won't kill us. Let's click on solver, and I'm going to solve for it. Okay. And then let's click at the reports. And let's see. Okay. And we should be good. There we go. And we'll keep the solver solution, so you can do that. And of course, your text is showing you some solutions, and it's going to run that solution for us. I hope. Software has been kind of sketchy here of late, so it's going to generate it, maybe. We'll see if it does or not. Go back down to the desktop level. Oh, I didn't want to do it. That's getting strange. I'm going to talk to the people at IT. Anyway, they show you the, you may be able to get it on your desktop there, but the, they show you the solution for that and the optimal objective value, and you're gaining from the original setup at leg 3, working with it, you've got 103. Now, one of the issues that always comes up with this is the fare is one thing, okay? The fare is something that's a competitive issue in terms of your pricing, but the demand is the one that's the trickiest, because you're going to have some pretty decent data to support what you think that demand will be. If the data are no good, you got a problem. Now, an airline like them or anybody is going to have a pretty good set of historical data. And one of the other things they can do, since they operate in such a fixed cost environment, because it's so capital intensive, and you see airlines and hotels do this, especially them, is that they will drop their prices tremendously to try to get as full a load as possible for that flight. So that's pretty much the leisure case. And again, this is just one of these ways in which we see in using revenue management, where we see where we can use the solver and we can use the optimization approach to deal with some of these issues. Now I want to diminish that down for just a second. I'm going to go back in here, and I've got the map there for it. And this will be, I think it'd be worth your while to go over there and take a look at that, that article, because the approaches that they use in the airline business is really not any different than what they do with hotels and motels, simply because fixed costs they have such an imbalance in terms of fixed cost. Now, I've got a case here for you called County, and I want to talk about it a little bit because it uses a kind of a different approach than you're normally going to see. So you ought to have your textbook with you, and if you don't, well, you can always come back and listen, because you'll miss a lot if you don't. And this is over on page 215. They introduced this notion of data envelopment analysis, okay? And if you take a look at 216, they talk about the input and the output measures, and then they talk about annual resources consumed by the 4 hospitals. And what they do in data envelopment analysis is this, is we create a composite, okay, of a system. Now there you have these different hospitals. I'll pop over here for just a minute. You see figure 5.1 over page 218. You've got these 1, 2, 3, 4 different hospitals, and then you have a composite. And the composite hospital is a statistically derived type of model based upon the other 4. And then what you do is you check to see, okay, is, for example, county, which is one of the hospitals, okay, is it as efficient or more efficient than the composite using the variables that you input and the function, the whole bit. And so you'll want to take a look at that. In the county case there, it's in the file and the resources. And this is one where we try to do some comparison, but we build essentially we build a composite or a statistical model, if you will, and compare it. And so what we're doing there is we're taking composites drawn from the 4 different hospitals. We put them into a model, and so really developing a model and then comparing everybody else against it. And that's what they do there with the county. So it's data envelopment analysis. It's used quite a bit, particularly when you work with we work with systems. And who all would use this? Well, these different hospitals, alliances would use it. Franchisers, retail franchisers use this model. Anybody who's got multiple stations or multiple workplace or multiple pieces of the system that they want to try to figure out, is it as efficient or inefficient as everybody else? And the focus is on that, because if it is as efficient or more efficient, then it's doing well. If it's less efficient than the model, then you've got to stop and say, okay, where did we go wrong? And you can read everything, but you're going to see the key variables. And this is there at the bottom of page 217. This is where experience, the industry setting, those types of issues come into play in terms of the weights that you apply to the inputs and outputs, and what you select for inputs and outputs to measure in the first place. Okay, and if you see at the bottom here, you've got these annual services, and these are outputs. Okay, and they've got Medicare patient days in the thousands, non-Medicare patient days, nurses trained, and interns trained. Now, each of these are revenue streams. The first is obvious. Their streams are paid by Medicare, paid by the government. The second, non-Medicare people who come in, they don't have Medicare or they don't need Medicare because of private insurance, or they're self-insured, or who knows what. And then nurses trained and interns trained. And what that basically is, they put a figure on that, because as you're training those nurses, you are getting paid for doing that, as well as for the interns who are trained in there as well, i.e. people who assist the licensed nurses, i.e. the people who assist the doctors. Now, I don't know, are these the right, are these the right output measures? I don't know. But let's take a look over on page 216, and you'll see the input measures, okay? And the number of FTE, non-physician personnel, okay? And the amount spent on supplies, and the number of bed days available. Now, if you look across the street over here, you're going to see that what used to be Shawnee Regional Hospital is now, I think, part of St. Anthony's. And it's interesting because things there have changed. You can just see it. Plus, they're expanding the place, trying to modernize it, upgrade it, etc. And it's interesting as I look at, because my own doctor's over there, I just kind of watch to see what does it look like, what are the loads, how many of us are sitting in his waiting room, etc. And if you take a look here, there's some things that there are some implications here. First of all, if you have non-physician personnel, okay, then you're going to be talking about nurses, which you want. Then everybody else becomes a question of should we have the position? So they engage in what's known often as what they call zero-sum budgeting, and that is, do we indeed need all these people up front? Now, when I go over to St. Anthony's, for example, I walk in there and I'll see about 6 kiosks or 6 stations where they do patient intake. All right, and so the patient intake, that's set up to maximize flow. And I've been in there at different times of the day just to kind of see what it looks like. And early in the morning, as you would suspect, there are lots of people in there, and they get funneled off over to if they're asked to get a blood sample, they get funneled on down to that department, maybe wherever they get funneled. But that's the hub of those intakes. And you can drive over there one of these days and get out and go inside and go and walk in. You'll see the hubs. And that's where people, you have the same insurance, and if you have a co-pay on business, and then they're fanned out to wherever they need to be. So what they're saying here is, first of all, how many people have we got here that are not directly serving a patient, okay, a physician, okay? Secondly, what are we spending on supplies, okay? Because it's easy for those kinds of things to get out of control. And then the number of bed days available, okay? And that is, how much capacity do we have? And this technique is used by every insurance company, every franchisors use this. This is typical model they use to devise a statistical model and then compare a location versus it. Now, the truth is, this is not any different than if you have a set of data and that you consider X data and Y data, and you run a correlation coefficient, because you're making an assumption there that those data have a certain type of fit, and you're assuming they're linear, okay? And so what we're doing here is we're making some assumptions about the outputs. You'll see that right there in the middle of page 218, the output for the composite hospital versus the output for the county hospital. This model has been used somewhat in less service intensive settings. And what I mean by that is in, let's say a big brokerage, attorney's offices, and you'll have law offices that will have 3 or 4 maybe locations. Not as much as it's used in more intensive service kinds of settings, meaning you have a lot of interaction with the customer or client. You utilize a lot of stuff in the process, and typically they are physically present with you. They come through and go through some kind of kiosk. So you'll want to take a look at county, and that's due on Friday, and play around with it. I gave you guys some variables to play with. I think maybe I didn't. Maybe I just asked you just to upload the thing, and then we'll try to play with it. Let's see here though. I'll go back over to the syllabus part and see if I'd given you some directions on county. And if not, we'll talk a little bit about it, because I think I have a county key over there where I did some manipulation. Again, what's important is not just running the model. No, I just have you upload the thing. What's important is that you understand the kinds of decisions and data to come up with this, okay? like page 220, okay? Now they show you the relationship between the input measures and the input for the hospitals, and then the input measures for the composite. What you're assuming there, okay, is number one, that you can build a viable composite. Number two, and I'm just walking it back. Number two, you're assuming that you've chosen the right variables. And number three, you're choosing that you've got good data from those variables. That is a lot. Those are a lot of assumptions, a ton of assumptions. And so you can put this stuff in, and it can end up being garbage if you don't, you know, if you're kind of clueless in terms of what you're doing, or if you don't really understand your industry, or you don't understand the business. And what will happen sometimes, it's not too much, but folks who are venture capitalists, okay, when they work with a franchise or multiple service unit type of business, say somebody has tire stores all over. This is one of their popular techniques, okay? But they'll build on some different kinds of, they'll build some different types of parameters into that, and then run those figures. And maybe it's of use, maybe it's helpful, maybe it's not. Again, as I've said, in case after case after case, if you input garbage, you're going to get garbage. You're going to get output that's garbage. That's all there is to it. So that one's going to be due on the 29th, and we'll go back over here, back to the modules for a second. Now the county case is over in the files area, okay, and that's in the files with all the other files that we're using for the course. And I think I might have put together a little, maybe thrown some variables and played with it just a little bit. We'll talk about it some next week in terms of what we're doing. But the whole idea is just to see, just to kind of get you acclimated to this model, and how it kind of just takes this whole approach and kind of elevates it past just a single operation. Page 221 really walks you through the whole bit there, and that's the minimize. It's a minimization problem, and it gives you the composite hospital, okay, and then you see the variables for county hospital, okay, and how it evaluates. And then over there on page 222, okay, they show you the solution for that, and whether or not it indeed is less, if it's equal to or less than the optimal objective. And they give you some interpretation, okay, and what the authors do in the middle of page 221, I want you to notice this. This is right at this in the middle there. They give you the composite score, okay? And the composite hospital can obtain at least the level of each output the county hospital obtains by having available no more than 90.5% of the input resources required by county hospital. So what they're saying is the composite says county is inefficient. There may be some intervening variables and so forth. At the very least, this type of tool is used to get people talking and thinking. And now, I would say if I were in this situation and I were really trying to look through this, all right, there's, in terms of the inputs, all right, I'd ask myself the question of, with the number of beds available, okay, are we a type of facility that draws a lot of people that are going to come in and take and use the beds? Are we going to be dealing with people, or are we going to be doing a lot of emergency room type of stuff? And that's where some of those kinds of things have to come into play because of the beds. The supplies too, what's the clientele we're dealing with, okay? And so this composite, before you could just say, well, the county hospital ought to be shut down because it's less efficient, or we need to fire some people or some crazy thing like that. You would want to start to then build out from it and say, okay, what kind of environment are they in? What type of patient do they serve? Okay. What types of nurses, trainees do we get through the door? What types of intern trainees do we get through the door? Etc. And start to build a little bit richer model. But if you really wanted to see how they kind of do this bare bones, franchises of all types, hospitals, you could probably also, an airline, any type of delivery system, you could run the same thing. You're going to have a different set of variables. In fact, my hunch would be that people like UPS and FedEx probably have one of these for every single route they run. And again, it's just trying to rationalize the system. That's all that they're trying to do is rationalize a little bit. And you'll be able to get them out of the files there. Okay. And there they are in county. And I'll just open this up for a minute. I'll download it. And county is going to be over there in chapter 5. And I don't have a problem if you open it up, okay, and mess with it a little bit. You know, and I would be fine if you do this. It's due Friday. If you downloaded it, you did some work with the variables, played around with it, okay, and insert a text message or insert a comment and tell me what you did and what it looked like. Part of this is to get you comfortable just playing with these, so when you're out in real life, you're okay with the software, and you're going to see products like this, or you're going to see people come in with data based on something like this, so that you can do what you're paid to do, and then is ask yourself, do I have the right input measures? Do I have the right output measures? And one of the things I've found is that most companies don't know what business they're in, and most of them really don't know who their competitors are. And so it's just endemic that you would, pardon me, it's imperative that you would want to have that type of data. So that's the county case. And again, I think it'd be worth your time to play around with it. The truck case here, this with Charlotte, this is a very simple model. You can imagine how complex it would get with Leisure Airlines if you had flights out of the hub, okay? And we'll go back here for just a moment, and I'm going to show you what they had done. Here's the map. What Leisure Airlines has done is they have mimicked the basic model that's used by everybody, but most effectively by really probably by Southwest, because they just have a flow through system. In other words, they have people flying in to Charlotte and then out. So they're running basically a north to south operation, and they're going after a market of people, I guess business people, probably vacationers, folks of that ilk, who are headed down there. And one of the reasons I did the map here was, if you're going to do something like this, okay, you need to have a sense of the spatial dynamics involved, okay? And you can pretty much figure, if you look at that map there, you can pretty much figure that during the summer and the spring, there's going to be a ton of storms down south. Okay, you might even get some hurricanes. And then in the winter up north, you've got two feeders that are going to experience all kinds of delays and problems because of bad winter weather. And so you're going to have to take that into mind when you work through the system. But again, it's always good to see how things flow, and they give you that there in terms of Leisure Airlines. Now, the county problem, it would be one that and I don't have any addresses or anything, but I want to know where are these people located, what kinds of neighborhoods, and what data do we have. For example, what type of data do we have on who in a given locale will use emergency and who will not? Okay, because it has a lot to do with it has a lot of implications in terms of the types of folks who come in, okay, Medicare versus non-Medicare, and so you've got those input measures and supplies and bed days available. If you have a hospital that serves a population that's highly bed intensive, just because of the nature of where they're at, you're not going to have many bed days available. You're going to have them filled up pretty full all the time, and that's going to impact you. Now, what we've done here, and again, I don't want to overemphasize the model and the software. What I do want to overemphasize, if I do anything, is the brain power behind what I put in the Waring blender, okay? How I mix this thing, how I use it, the input variables and the output variables. Because if I got it wrong, I've really got it wrong. And the worst thing is, if I've got it wrong, now I have some data in my pocket, and there's nothing worse than somebody who's got a data model that's completely off the charts. That's no good. It's useless. So that's why I was going to ask you to take a look at there and play with county. Let's see what else we got going on this week. I'll take us down here. We've looked at the leisure. Another is going to be the Foster case. And page Foster's on. Foster's over on pages 308 to 310, appendix 6.1. So if you got your book with you, or you ought to have it with you, go over to page 308. Okay, and this is Foster generators. In fact, they show you there on page 309, appendix 6.1, the Excel solution. And what these folks are working with is a transportation problem, okay? Transportation problems are those where instead of things inputs like people and supplies, now we're talking distance, okay? And we may be even talking distance and weight, and that makes all of it that much more complicated. Now, I can assure you, okay, that this morning, even as I speak, there are people at FEMA, people at the Red Cross, people at these different at these states that have been affected by these hurricanes, the military, everybody, every major agency that's working with those people are running these models over and over and over to find out, okay, how can we get things marshaled and gathered and get them there as efficiently as possible? And how do we do that without infrastructure? The same thing is for the people there in Mexico City, and in terms of trying to catalog, okay, what damage, first of all, who do we need to get out from under rubble that might be alive? Then, what buildings are likely to fall within the next week? Because if you don't find those buildings and it collapses, then you got another disaster on your hands. And then you got to figure out, okay, what infrastructure has been affected and impacted. The problem that the people in Mexico City have is they live on top of a very unique type of they live basically on top of an aquifer. A lot of people don't know this, but Mexico City, like Chicago, is built on a swamp, the city of Chicago. And the name is an Indian name, I think, for stinking water, if I'm not mistaken. But there's a great article in the New York Times that shows how, because where that city is built on that more liquid type of soil, that when they have a earthquake, it shows the different levels of shaking that you get and the direction of it. And so things get really magnified there because of the type of ground they have. The same thing in California and here in Oklahoma to a certain extent, because we have such a sandy base. People will feel earthquakes of a magnitude that aren't really that great, but it's because because of the nature of the ground, it's more porous, so it carries. Well, I started about 5 or 6 minutes early, and I think we've pretty much gone through where we're at. So the Foster case is the one that you'll want to look at it, and they've got the formulation for that as well, and the parameters and the solution. That one is a transportation problem, and so I want you to take a look at it as well. And that will pretty much do it for today. And I'll do a screencast on Wednesday. Now, what I'll do on Wednesday is I'm going to focus. And you also have Gorman, so you'll want to take a look at Gorman. Again, if I ask you to change some parameters, do so. If not, just upload it, because we'll come back and take a look at it and dissect it. But what I will do on Wednesday is I'm going to talk about network structures and logistics, and I've got some other things there for you on Humanitarian Logistics Association, what they do, and then some research studies using the data development analysis technique. So thank you for your time, and I'm going to stop the share. And boy, I have a whole lot of you, so I want to say thanks to everybody. There's Alexa, Alexander, Allison, let's see, I've got Amanda. And guys, if you came in late, it's going to be Bo and Jan, Suzanne, Tyler, and Caleb. And I'm going to save this, and once it's posted, if you came in a little bit late, then you can catch up on what we missed. And then I'll do a screencast on Wednesday. So thank you, folks. Appreciate the time. And I'll stop the